again, and I'm discussing the pre-lab activity for lab 6.2. This is a dry lab, and it's the pre-lab is due on October 3rd by 4:30 p.m. So let's look at an overall view of what we're going to do in the lab, and then we'll talk about the pre-lab. So it says in this lab activity your goal is to recreate a portion of the modern periodic table using physical and chemical data for a set of 14 elements. Working in teams and signed by your instructor, and by the way, that will be in your pod, so most of you work in groups of 4, some of you groups of 3. You will receive the element data in 4 sets, 1 set at a time. After receiving a data set, your team will work to discover trends in the data and to organize or reorganize elements by these 3 different categories: type, group, and period. So I'd like to give you a little bit of background as to the periodic table. So I'm going to read out of a book called Mendeleev's Dream. And of course, Mendeleev was one of the first discoverers. He's given credit for discovering the periodic table. And so here's a picture of Mendeleev. He's a Russian, and back in the 1800s is when he discovered it. So we're going to look at how he discovered it, and you're going to recreate that discovery in the same kind of manner that he did. So we'll look at how he did that. He worked on it for 3 days straight, not even spending time to sleep. So 3 days and 3 nights. And it tells us in the book he was in such a depressed state that he was found by his friend in Nostrovzev when he called round to see Mendeleev on the afternoon of the 17th of February. That would be 1869. Mendeleev knew he was on the verge of a great discovery, but he just couldn't grasp it. "It's all formed in my head," he complained bitterly, "but I can't express it." Exhausted, he rested his shaggy head in his hands. Passing over the dubious philosophy implicit in this remark, one can certainly sense Mendeleev's frustration. Once again, it was getting late. He was supposed to go to, he's supposed to take a train and go for a trip to consult with a company. But he didn't go. There was simply no time to explore every avenue of possibility amongst the sea of cards spread before him. No time for meditating on the pros and cons of each alternative scheme. He had to act quickly, guess, rely on his intuition, decide. Fortunately, Mendeleev's intuition was one of his main strengths. So what he had was cards with the elements on them and their properties, that being physical properties such as melting point, boiling point, and chemical reactivity, so some chemical properties. And he was shuffling them similar to what he called the game of patience. It's similar to what we have as solitaire now. So I want to show a demonstration of that. So these are playing cards right here. And so he was arranging them by suit. So he had them sideways. So here we have some hearts, and here's another heart. So you put the lesser heart to the right. So here we have a 10 and an 8 of hearts. And now our next card is an ace of clubs. So let's move this so we can see. And then another ace, but it's an ace of diamonds, or ace of spades, I'm sorry. And so we'll put that there. And then we have a 2 of diamonds, so that's yet another suit. So we'll jam these a little bit closer here so we can see the 2 of diamonds. And then the next one is queen of spades, so we're going to put her here, but we know the king goes in between. So we're putting them not only by suit, or suite I should say, but also by in order of the number. So this is a heart, so this would go down after the 8. And here we have a 7 of diamonds, so that would go in front of the 2 of diamonds. Or to the left, I should say, the 2 of diamonds. Here's a king of clubs, so we'll put him there. And now we have a 9 of spades, so it goes here. We have a 3 of diamonds, so it goes in between the 7 and the 2. And we have an 8 of clubs, so there it goes, and a jack of clubs, so it goes between the king and the 8. So you can see there's a pattern to this, and we could call it a repeatable pattern, so that we're putting all of the ones that are hearts together, all the clubs together, and then we put them in order of their value to us. So an ace has more value than a king, and a king has more value than jack. a 10 has more value than an 8, and an 8 has more value than a 3. So we call this table, and so I'm going to continue to read that Mendeleev was trying to set the chemical cards for each element. He had a card, and he was trying to set them up in some kind of repeating pattern like this. So let's see what he came up with here. He called it the game of chemical patience. It evidently confirmed and seemed to point beyond Mendeleev's initial insight concerning the emergent but nonetheless flawed pattern among the halogens, the oxygen, and nitrogen groups. Everything seemed to be coming together. By now, the fading dusk outside the window had given way to the frigid darkness of night. He was in Russia, close to Moscow. Despite his growing exhaustion, he knew he couldn't stop now. He was possessed by the feeling he was on the brink of a momentous discovery. So it comes as something of a disappointment to record that at this point he was overcome with fatigue. He leaned forward, resting his head on his arms amidst the scattered cards on his desktop, and he fell asleep and had a dream. So he wrote in his own words, I saw in a dream a table where all the elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. In his dream, Mendeleev had realized that when the elements were listed in order of their atomic weights, their properties repeated in a series of periodic intervals. For this reason, he named this discovery the periodic table of the elements. And this was the setup he had. Of course, this is in a different language, in Russian. And so you can see he had things listed. We had copper, then silver, and then mercury. And we have things in, he put them down. As you go down, they increase in their weight. This is their atomic weights. Now, we now know that this wasn't the absolutely correct way. He had some things out of order. So for instance, here he has 122, then 128, then 127, and of course he was arrogant enough, as a lot of scientists are, to say, well, they didn't do the weights right. They had the wrong atomic weights. But we now know that it's a different order than atomic weights, but atomic weights was a good starting point for him to be, and he published, and he was the first one to publish on this table. So we have the periodicity of the trends of the chemical and physical properties, mainly the chemical properties of the elements. So what you're going to do is similar to what Mendeleev did with his cards of the different elements, similar to the way we do playing cards, and these are going to be the cards you get. So you're going to get different cards, and these numbers here are just codes. They have nothing to do with the atomic mass or the atomic number or anything like that. So you can see you'll get the discovery date, the state at 25 degrees, whether it's a solid or a gas, and there are some liquids. Then the atomic volume, the thermal conductivity, and so you will get this information and you will try to arrange them in a pattern. So perhaps you'll want to go by atomic volume and go from little to big, and you can see that 17, and then you would skip to 18 and go back to 19. So you'll have these on index cards, and you will organize them in a way. So that'll be one set. Then after you have them organized, you may want to look at some more data, some more physical characteristics. So here you'll have a set of cards with the melting point, the boiling point, the density. And so these are chemical or physical properties, and then you'll start getting the chemical properties. So you can see that this element forms with 3 hydrogens, and so this element is also with 3 hydrogens. This one is just 1 hydrogen, and this one is 3. So perhaps you'd want to organize the 3s together and then see if you can find another one that has just 1 hydrogen with it, and put that in a category together. Here's one over here with just the 1 hydrogen. So that would be starting in on the chemical properties. Then after that, after you have those organized, you'll get I apologize for the way my nails look. I feel bad because I just got off the golf course, so that's one reason they're so dirty. I should have washed better. Okay, so then we have electronegativity. So this has got to do with atomic structure, electron affinity, ionization, energies, and the size of the element when it forms a compound with something else, the covalent, meaning a shared bond. What size does it take up? So those are in picometers, so that's another set of data. And then the last data will be the actual group it's in, whether it's a main group metal or semi-metal or non-metal, and then you'll get its effective nuclear charge and the electron configuration. So then this will really help you. But Mendeleev didn't have this kind of information. He did have whether it was a main group, whether it was a metal or a non-metal. So he did know those things, but he did not know the effective nuclear charge. He had to go by the chemical properties rather than something more as to the actual structure of the atomic element. So that's what your that's the basis for what you're going to be doing in lab. So now let's go to the pre-lab. Finally, huh? So where is it? Here we are. In fact, I'm going to stop it now, and we'll go to a second recording for that.